Good afternoon, everyone. Welcome to I Square Maths Academy, where numbers and variables actually meet mastery. Today, we are going to be looking at another form of ordinary differential equation, that is first order differential equation, the homogeneous equation. Yes, homogeneous equation is actually applied by substituting the value y is equal to vx. Yes. Now, the homogeneous equation is actually used or applied when the equations, the variables cannot be separated. Just like the first case, the first topic on ordinary differential equation, where we actually looked at separating variables using the separation of variables method. But in this case, the variables cannot be separated. So because the variable cannot be separated, we call it the homogeneous equation. So the relationship between x and y is much more involved. So here we have some questions, so examples. Yes, we have 5 questions here to solve. Yes, to explain the homogeneous equation. Now, question number 1. Question number 1. Here we have x raised to the power of 3 plus y raised to the power of 3 is equal to 3xy squared, the y all over dx. Yes. So in this case, we are going to substitute y is equal to vx. Yes. So here, substitute y is equal to vx. Now, let's look at this. If y is equal to vx, let's see the y all over dx. Now, remember the product rule. Yes, remember the product rule, where we said if y is equal to uv, that the y all over dx is v the u all over dx plus u the v all over dx. So here, applying the product rule here, you pick x. Then here we have the v all over dx plus v. Now when you differentiate x, we have 1. So the y all over dx will be equal to, we have x, the v all over dx plus v. Now let's take note of this. Yes, let's take note of this. Yes. The y dx is equal to x, the v all over dx plus v. Now remember we said let y be equal to vx. So it means anywhere we see y here, we are substituting vx. Yes, we are substituting y for vx. So it means here we have x raised to the power of 3 plus the value of y here becomes vx all raised to the power of 3 is equal to, here we have 3x, y squared becomes vx all raised to the power of 2. Then here we have the y all over dx. Yes, the y all over dx. So it therefore means that here x raised to the power of 3 plus vx raised to the power of 3 will give us v raised to the power of 3 and x raised to the power of 3. Now this will give us 3x in brackets. Here we have v squared, x squared, then the y all over dx. So it therefore means that here x raised to the power of 3 plus v raised to the power of 3, x raised to the power of 3 will be equal to, now multiplying this, 3x times v squared x squared, that will give us 3x raised to the power of 3. Yes. And here we have v squared, the y all over dx. Yes, the y all over dx. So now it means here we have x raised to the power of 3 plus v raised to the power of 3, x raised to the power of 3 is equal to 3x raised to the power of 3 v squared. Then we have the y all over dx. Now let's divide through. Let's divide through by 3x raised to the power of 3, then v squared. So it means here we have x raised to the power of 3 plus v raised to the power of 3, x raised to the power of 3, all over 3x raised to the power of 3. Then here we have v squared is equal to the y all over dx. Yes. It therefore means that the y all over dx will be equal to, now in the numerator, x raised to the power of 3 is common. Yes, x cube is common. It means here we have x cube in bracket 1 plus v raised to the power of 3 all over 3x raised to the power of 3. Then here we have v squared. Now looking at this x raised to the power of 3 will go with this x raised to the power of 3. So we'll be left with the y all over the x will be equal to, we have 1 plus v raised to the power of 3 all over 3v squared. Yes. But recall from here that the y all over the x is x the v all over the x plus v. So it means here we have x the v all over the x plus v is equal to 1 plus v raised to the power of 3 all over 3v squared. Yes. So here, x the v all over the x will be equal to, now taking this plus v to the other side, it becomes 1 plus v raised to the power of 3 all over 3v squared minus v. Yes, it is v, minus v. So it therefore means that here we have x the v all over the x the v all over the x will be equal to, we have 1 plus v raised to the power of 3 all over 3v squared minus v all over 1. Yes, v is essentially the same v all over 1. Okay, so here let's look at the LCM. The LCM of 3v squared and 1 is 3v squared. 3v squared into 3v squared is 1. And 1 times 1 plus v cubed is 1 plus v cubed. Yes, 1 plus v raised to the power of 3. Then minus 1 into 3v squared is 3v squared times v. We have v in bracket 3v squared. So it therefore means that x the v all over the x will be equal to, we have 1 plus v raised to the power of 3 minus 3v raised to the power of 3 divided by 3v squared. Yes, divide by 3v squared. So it means x the v all over the x the v all over the x will be equal to, here we have 1 minus, yes, because v raised to the power of 3 minus 3v raised to the power of 3 is minus 2v raised to the power of 3 all over 3v squared. Yes, so at this point we can use the separation of variables. Yes, so it means here we have 3v squared all over 1 minus 2v raised to the power of 3. The v will be equal to, we have 1 all over x. Then here we have dx. Yes, 3v squared all over 1 minus 2v raised to the power of 3 dv is equal to 1 all over x dx. So at this point, now we can integrate both sides. So integrating both sides. So now let's look at, first of all, let's look at the left-hand side. Let's look at the left-hand side. Yes, left-hand side. So let me put it here, left-hand side. So for the left-hand side, we have integral 3v squared all over 1 minus 2v raised to the power of 3 dv. Yes, so to integrate this, let u be equal to 1 minus 2v raised to the power of 3. Yes, let u be equal to 1 minus 2v raised to the power of 3. So it means the u all over dv, yes, the u all over dv will be minus 6v raised to the power of 2. Yes, the u all over dv is minus 6v raised to the power of 2. Now let's see the u. Our du will be equal to minus 6v squared. Then here we have the v. Yes, cross multiplying, because this is the same thing as over 1. When you cross multiply, we have the u is 6 minus 6v squared, the v. So it therefore means that the v will be equal to minus the u all over 6v squared. Or we can call this the u all over minus 6v squared. It's the same thing. So it therefore means that at this point, the whole of this now, integral 3v squared all over 1 minus 2v raised to the power of 3, the v will be equal to integral, here we have 3v squared all over 1 minus 2v raised to the power of 3. We say let it be u. So it means here we have all over u times the v is the u all over minus 6v squared. So here we have the u all over minus 6v squared. So it therefore means that the whole of this now will be equal to, here, 3 here is 1, 3 into 6 is 2. Those v squared will go with this v squared. So it means we'll be left with minus 1 all over 2 integral 1 all over u. Then here we have the u. Yes, minus 1 all over 2 integral 1 all over u du. Now it means here the value here will give us integral 3v squared all over 1 minus 2v raised to the power of 3. The v will give us, we have minus 1 all over 2 minus 1 all over 2 ln u. Yes, minus 1 all over 2 ln u. Because when you integrate 1 over u, it gives ln u. So it therefore means that the whole of this now will be equal to minus 1 all over 2 ln the value of our u. And remember, u is 1 minus 2v raised to the power of 3. So here we have 1 minus 2v raised to the power of 3. Yes, so it means here this will be minus 1 over 2 ln 1 minus 2 in bracket the value of v. Now remember we said we actually substitute y to be equal to vx. Y to be equal to vx. And if y is equal to vx, it means the value of our v will be y all over x. Now take note of this. If y is equal to vx, it means the value of v will be y all over x. So here we have y all over x all raised to the power of 3. Yes, so that is the left hand side. Now let's look at the right hand side. Right hand side. Okay, so now integrating 1 all over x dx. When you integrate 1 over x, it gives ln x plus constant. Yes, it gives ln x plus c. So remember we said, remember right hand side is equal to left hand side. Okay, or let me call it left hand side. Left hand side is equal to right hand side. So it therefore means that the whole of this, yes, that's the left hand side, minus 1 all over 2 ln 1 minus 2y raised to the power of 3 all over x raised to the power of 3 is equal to, now the right hand side, we have ln x plus c. Yes, we have ln x plus c. Now let's multiply 2 by minus 2. Yes, let's multiply 2 by minus 2. Multiply 2 by minus 2. Yes, so when you multiply 2 by minus 2, it means here we have minus 2 in brackets, minus 1 all over 2, we have ln 1 minus 2y raised to the power of 3 all over x raised to the power of 3, yes, is equal to minus 2. Then here we have ln x plus c. Yes, ln x plus c. So here this will go with this. This will go with this because here we know minus times minus is plus. So here we have ln in bracket 1 minus 2y raised to the power of 3 all over x power 3 will be equal to, here we have minus 2 ln x minus 2c. Okay, then remember c is an arbitrary constant. It means we can call this ln 1 minus 2y raised to the power of 3 all over x power 3 is equal to, we have minus 2 ln x, I can call this plus a. Yes, I can call minus 2ca. So it means in this case, we have this, so this is the same as saying ln, we have this times this minus this over this. X raised to the power of 3 times 1 minus 2y raised to the power of 3 divided by x power 3. So we have x power 3 minus 2y power 3 all over x raised to the power of 3. Yes. Now, bringing this inside to the left hand side, we have plus 2 ln x is equal to a. Yes, it's equal to a. So it therefore means that here is the same as saying ln x raised to the power of 3 minus 2y raised to the power of 3 all over x power 3 plus, it is the same as saying ln x raised to the power of 2. Yes, ln x raised to the power of 2. Now the whole of this is equal to a. Yes. Now applying one of the laws of logarithm. Yes. Here we have ln x raised to the power of 3 minus 2y raised to the power of 3 all over x raised to the power of 3 times the value of our x squared. Yes, x squared is equal to a. Yes, it's equal to a. Yes, because we said log A plus log B is the same thing as log AB. Yes, so that's exactly what we apply there. Log this plus log this, you just multiply the functions, the values. So here, what we have here now will be, now the x squared will cancel, will reduce the x raised to the power of 3. Now let's look at it. Here we have x squared, here we'll be left with x. So it means here we have ln x raised to the power of 3 minus 2y raised to the power of 3 all over x is equal to, we have e. Yes, we have e. Now but remember, this is the same as saying log x raised to the power of 3 minus 2y raised to the power of 3 all over x to base e. Now this is equal to e. So it therefore means that x raised to the power of 3 minus 2y raised to the power of 3 all over all over x will be equal to e raised to the power of e. Now remember the definition of logarithm. We said the logarithm of a number to a given base is any power to which the base can be raised to give the number. It therefore means that this is the same thing as e raised to the power of e. So it means here x power 3 minus 2y raised to the power of 3 will be equal to x e raised to the power of e. Yes, it will be x e raised to the power of e. That's cross multiplying because this is the same thing as over 1. So this times 1 will give you this, x times this will give us this. Okay, x times e power a will give us x e power e. So it means at this point, x raised to the power of 3 minus x e raised to the power of a will be equal to 2y raised to the power of 3. Yes, so if it is equal to 2y raised to the power of 3, it means 2y power 3 is equal to x power 3 minus x e raised to the power of e. And the value of y power 3 will be equal to x raised to the power of 3 minus x e raised to the power of a divided by 2. So this is our y raised to the power of 3. So this is a relationship between x and y. Though this can be expressed in other forms. Yes, you can express this in other forms. So but here, we can stop here. Okay? Yes, I want to stop here. So now we are going straight to question number 2. So we're done with question number 1. Now I want us to look at question number 2. Yes, question number 2. Now for question number 2, we have xy plus y squared plus x squared minus xy, the y all over the x is equal to 0. Yes, it's equal to 0. So if this function is equal to 0, it therefore means that x squared minus xy, the y all over the x will be equal to minus, we have xy plus y squared. Yes, we have minus xy plus y squared. It therefore means that the y all over the x will be equal to, we have minus xy plus y squared all over x squared minus xy. Yes, all over x squared minus xy. So here, substituting Yes, substitute y is equal to vx. Y is equal to vx. And remember, if y is equal to vx, it means the y all over the x will be equal to v, you differentiate this, that's 1, plus x. You differentiate v now, that will be the v all over the x. So it means the y all over the x will be equal to v plus x, the y, the v all over the x. Now let's take note of this. Let's also take note of this. Yes. Now in this case, we want to substitute y to be equal to vx. So it therefore means that anywhere we see y in the equation, we are putting vx there. So now let's look at the y dx. Now the y all over the x will be equal to, here we have minus. Then xy, we have x. In place of y, we have vx. Yes, plus y squared. So that will give us vx all squared. Yes, vx all squared. Now all over, here we have x squared minus xy. So it will be x. Then here we have vx. Because we said let y be equal to vx. So now let's see the y dx. Now the y all over the x, or the y over the x rather, the y all over the x will be equal to, now we have minus. Now let's look at this. V times x times vx, that will give us vx squared. Vx squared plus, now let's look at vx squared. That is vx times another vx. That will give us v squared x squared. V squared x squared. Now all over, now here we have x squared. We have x squared minus x times vx. That will give us vx squared. Yes. So it means the y all over the x, the y dx will be equal to, we have minus. Now looking at this here, x squared is common. So we have x squared. So here we'll be left with v plus, we have v plus v squared. Yes, v plus v squared all over. Here we have x squared to be common. So here we have 1 minus v. Yes. So in the numerator, we actually factored out x squared. Yes. And we're left with v plus v squared. Then now, here, the denominator, x squared is common. So we factored out x squared. So we have x squared in bracket 1 minus v. So this x squared will go with this x squared. So the y all over the x will be equal to, we have minus v plus v squared all over. Here we have 1 minus v. Now, but recall that the y all over the x, the y all over the x is equal to v plus x the v all over v plus x the v all over the x. Yes, so that's the y dx. So now putting it here in this equation, we have v plus x the v all over the x will be equal to minus, in bracket, v plus v squared all over 1 minus v. Yes, all over 1 minus v. Now let's see x the v all over the x. Now collecting like terms, I want to take the value of this v to the other side, to the right hand side. Yes, so taking v to the right hand side, we have x the v all over the x. X the v all over the x will be equal to, we have minus v plus, we have v squared all over 1 minus v. And here we have minus v. Yes, taking this plus v to the other side, that's minus v. So here we have minus v all over 1. Now the LCM of 1 minus v and 1 is 1 minus v. 1 minus v into 1 minus v is 1. 1 times this, it becomes minus 1 in bracket v plus v squared minus 1 into 1 minus v is 1 minus v. 1 minus v times v becomes v in bracket 1 minus v. Yes. So it therefore means that x the v all over the x, x the v all over the x will be equal to minus 1 times v is minus v. Minus 1 times v squared is minus v squared. Minus v times 1 is minus v. Minus v times minus v. That will be plus v squared. All over 1 minus v. Yes, all over 1 minus v. So it therefore means that here, this minus v squared, we'll go with this minus, we'll go with the plus minus v squared. So it means x, the v all over the x will be equal to, so here we have minus 2v all over 1 minus v. Yes. So now at this point, we can separate the variables. Yes, we can separate the variables. So separating the variables, we have 1 minus v all over minus 2v. The v is equal to 1 all over x. Then here we have the x. Yes, we have the x there. So this is the same as saying, let's multiply 2 by minus 1. Multiply 2 by minus 1. So when you multiply this by minus 1, we have 1 minus v all over 2v. Yes, the minus changes minus to positive. Is equal to, we have minus 1 all over x. Then here we have the x. Now, so here we have the v. So it's equal to minus 1 all over x dx. So at this point, we have to integrate both sides. Since we've been able to separate the variables, we have separated the variables. So now we are integrating both sides. So integrate both sides. Okay, so now let's look at the other side. So we have integral 1 minus v all over 2v. Then here we have the v is equal to integral minus 1 all over x dx. So now let's look at the left hand side. Yes, the left hand side. So integral 1 minus v all over 2v. The v is the same as saying integral 1 all over 2v. Yes, minus v all over 2v. Then here we have the v. Now this is the same as saying integral 1 all over 2v. Then here we have the v minus integral v all over 2v. Then here we have the v. So this is the same thing as saying 1 all over 2 integral 1 over v, the v minus integral. Now this v will go with this v. So we left is 1 all over 2 the v. So this is equal to, we have 1 all over 2. When you integrate 1 over v, it becomes ln v minus, here we have 1 over 2. When you integrate the v, it becomes v. Okay, it becomes v. So at this point, we have 1 all over 2 ln v minus 1 all over 2v. Okay, now let's look at the right hand side. Right hand side. Now for the right hand side, we have integral minus 1 all over x dx. That will be equal to minus integral 1 over x. Then here we have the x. So this will be minus ln x plus c. Yes, minus ln x plus c. Now remember, left hand side is equal to right hand side. So it means, now let's look at it. Left hand side is equal to, or left hand side is equal to right hand side. So for the left hand side, we have 1 all over 2 ln v minus 1 over 2v is equal to minus ln x plus c. Yes. Now let's multiply 2 by 2. Multiply 2 by 2. So if you multiply 2 by 2, you have 2 in brackets, 1 over 2 ln v minus half v is equal to 2 in bracket minus ln x plus c. So expanding this, these two will go with this 2. We have ln v minus v. Yes, because 2 will cancel this 2, we have ln v. 2 will cancel this 2, we have v. Is equal to, we have minus 2 ln x plus 2c. Yes, plus 2c. So it therefore means that here we'll have it as ln v minus v, ln v minus v will be equal to, here we have minus 2 ln x, then here we have plus a. Yes, since c is an arbitrary constant, so it means 2c can be expressed as a. So it means here we have ln v minus v plus 2 ln x is equal to a. Yes, it's equal to a. So at this point, this is the same as saying ln v plus ln, this 2 ln x is same as ln x squared minus v is equal to a. Now let's recall, yes, that y is equal to vx, and if y is equal to vx, it means our v will be equal to y all over x. Yes, so it therefore means that here we have ln y all over x plus ln x squared minus y all over x is equal to a. So this will be ln y over x times x squared, yes, minus y all over x is equal to a. So at this point, this x will cancel, x here is 1, x into x squared is x. So we have ln yx, yes, ln yx minus y all over x will be equal to a. So this is the equation. So here we can also express it in other forms. Yes, we can express it in other forms. But here we have ln yx minus y all over x is equal to a. Yes, so that's the solution to question number 2. Now let's look at question number 3. Yes, question number 3. Now, question number 3, we have x squared plus y squared, the y dx, the y all over dx is equal to xy. Yes, equal to xy. So it means the y all over dx will be equal to xy all over x squared plus y squared. Yes, xy all over x squared plus y squared. So here, now put y is equal to vx. Yes, y is equal to vx. And remember, if y is equal to vx, it means the y all over the x will be equal to, we have v plus x, the v all over dx as the value of the y dx. Now let's look at the equation again. Let's look at this equation again. So here we have the y all over the x will be equal to xy. Our x is x, then the value of y is vx. So here we have vx all over, we have x squared plus y squared, and y is vx. So we have vx squared. So it means the y all over the x will be equal to vx times x. That will be vx squared. All over here we have x squared plus v squared x squared. So here we have the y all over the x. The y all over the x will be equal to, here we have vx squared all over x squared is common here. So we have x squared in bracket 1 plus v squared. Yes, in bracket 1 plus v squared. So this x squared will go with this x squared. So it means we'll be left with the y all over the x. Yes, the y all over the x. The y all over the x will be equal to, here we have v all over 1 plus v squared. Then recall, the value of the y over the x, the y all over the x is also equal to, we have v plus x, the v all over the x. V plus x, the v all over dx. So therefore means that the whole of this time is equal to this. Since the y dx is equal to v plus x, the v dx, and the y dx is v all over 1 plus v squared. So therefore means that v plus x, the v all over dx will be equal to v all over 1 plus v squared. Yes, v all over 1 plus v squared. So it means here, x, the v all over the x will be equal to v all over 1 plus v squared minus v all over 1. Yes, minus v all over 1. So here the LCM here of 1 plus v squared and 1 is 1 plus v squared. So this into this is 1. 1 times v is v. Minus 1 into this is this times v. That will be v in bracket 1 plus v squared. So it means x, the v all over the x, will be equal to, we have v minus v, because minus v times 1 is minus v. Minus v times v squared, that will be minus v raised to the power of 3. Now, all over 1 plus v squared. Yes, all over 1 plus v squared. Now, this v will go with this v. Yes, this v will go with this v. So it means we will left it x, the v all over the x, x, the v all over the x will be equal to, now let's look at this, v minus v gone. So we have minus v raised to the power of 3 all over, we have 1 plus v squared. Yes, 1 plus v squared. So it therefore means that here, separating the variables, we have 1 plus v squared all over minus v raised to the power of 3. The v will be equal to 1 all over x, then here we have dx. 1 all over x dx. So it means the whole of this now will be equal to, we have minus 1 all over v raised to the power of 3. Yes, minus 1 all over v raised to the power of 3. Now this divided by this, then here we have minus, we have v squared all over v raised to the power of 3. The v will be equal to 1 all over x, then here we have dx. Now this is the same as saying minus v raised to the power of minus 3. Yes, 1 all over v raised to the power of 3 is the same as v power minus 3. Then this v squared here, we're going to this, we have 1 all over v. Yes, v squared here is 1, v squared into v power 3 is v. So here we have the v is equal to 1 all over x dx. So at this point, we are going to be integrating both sides. So integrating both sides, so here we have integral minus v power minus 3 minus 1 over v. Then here we have the v is equal to integral 1 over x. Then here we have dx. So it means here we have integrating minus v raised to the power of 3. We have minus v raised to the power of minus 3 plus 1 all over minus 3 plus 1. Then here we have minus ln v. Yes, when you integrate 1 over v, it gives ln v is equal to ln x plus c. Yes, it's equal to ln x plus c. So this is the same as saying minus v raised to the power of minus 2 all over minus 2 plus ln v is equal to ln x plus c. So minus minus we turn to plus. So we have v squared, v raised to the power of minus 2 rather, all over 2. Because here, there's minus and there's another minus here. And minus divided by minus is plus. So you see here, the minus actually vanished. So here we have plus. Sorry, this is minus. Minus ln v. Yes, minus ln v is equal to ln x, then here we have plus c. Yes, plus c. So this is the same as saying 1 all over 2v squared. Yes, 1 all over 2v squared minus ln v is equal to ln x plus c. But recall, yes, y is equal to vx. And if y is equal to vx, it means our v will be equal to y all over x. Yes, v is y all over x. So it means the whole of this now will be equal to, yes, it will be equal to, we have 1 all over 2 in brackets, v is y all over x. So we have y all over x all squared minus ln y all over x. Please, this is y all over x is equal to ln x plus c. Yes, it's equal to ln x plus c. So it means here we have 1 all over, here we have 2y squared divided by x squared. Yes, because this is y squared all over x squared. Yes, so minus ln y all over x will be equal to ln x plus c. Now the whole of this will be equal to x squared all over 2y squared minus ln y all over x minus ln x is equal to c. So this is the same as saying x squared all over 2y squared minus in brackets we have ln y all over x plus ln x is equal to c. Yes, so here we have x squared all over 2y squared minus, now this is the same as saying ln y all over x times x. Now the whole of this is equal to c. Okay, so it means x squared all over y squared. So here we have x squared all over 2y squared minus c is equal to, we have ln y. Yes, we have ln y because this x will cancel this x. Yes, this x will cancel this x. So it means here we have ln y is equal to x squared all over 2y squared minus c. Yes, minus c. So at this point, we can stop here. Yes, we can stop here. So ln y is equal to x squared all over 2y squared minus c. So we have solved question 2 and we have also solved question 3. So at this point, I'm going to leave question number 4 and question number 5 for you to try, do as an assignment. And if you have any problem, you can contact me and I will demystify it for you. Thank you for listening and God bless you.